Hello, everyone, and welcome to the EVN Disrupt podcast. My name is Najdat Zaturyan. I'm the editor of the Creative Tech section here at EVN Report. Our guest this week is Davit Buniatyan, the co-founder and CEO of Activeloop, a data infrastructure company that has built Deep Lake, an optimized data lake for deep learning. We spoke about why deep learning needs optimized data infrastructures, how the MLOps ecosystem is changing with the rise of foundational models such as GPT, and where multimodal models fit in the future of AI. Davit-jan, thank you so much for being here today.
Likewise, thanks for the invite. Super excited to be here.
Absolutely. Davit, let's start with a little bit of your background. Tell us where you studied, how you got interested into computer science.
So I'm originally from Yerevan. I did my high school at Quantum College here. And then the last 2 years I did at IB school. Then got accepted to UCL, which is in London. Did computer science there. Then after 3 years of studying there for bachelor's, moved to US to start my PhD in Princeton doing computer science. So actually when I got into computer science, I got into a computer vision lab, but my advisor, he left to Bay Area to start his own self-driving car company. So I had to find another advisor and I got into neuroscience.
Right.
And in neuroscience, we're doing connectomics research, which I'll get into details if it's interesting.
Before we get to Princeton, you said your last 2 years you studied at an IB school. Was that UWC or?
Oh, no, actually Quantum.
Oh, at Quantum.
School, Quantum did the first IB school here, even before UWC and other schools here. Yeah. So we were like the experiment group to try here.
It's interesting. Armenia. We've done about like 40 of these podcasts, and without exaggeration, more than half are either phys-math or quant grads. So it's interesting how these specialized high schools play such an important role in developing entrepreneurs and engineering talent like yourself. I'm really curious about your time at Princeton, because you said that you were studying computer science, but at some point you took more of a neuroscience direction. Tell us about the neuroscience part.
Yeah, so when I got accepted, actually all the deep learning professors, the professors who were doing research in deep learning, they were left, and there's only one left at neuroscience department, and his name is Sebastian Son, and he was doing this connectomics research. And connectomics is basically a new branch in neuroscience that tries to reconstruct the connectivity of neurons inside the brain. So what we were doing, we were taking 1 millimeter volume of a mouse brain, cutting into very thin slices. Each slice is like 100,000 by 100,000 pixels. And if you look into the resolution, each pixel is like 4 nanometers by 4 nanometers. And the depth is like 40 nanometers. So it's like a super high resolution electron microscopy images. And the problem was to use deep learning to separate the neurons from each other, find the synapses, and then reconstruct the graph of how each neuron is connected to each one. So maybe give you an example. Like, you do know that inside your brain, you have a neuron that's named after Jennifer Aniston. So what happened is that there was a patient where they were giving a lot of images of different people, different celebrities, and when they saw like the Jennifer Aniston face, exactly that neuron was firing up.
Right.
And the question is why that neuron fires. What is it connected to? What the previous neurons were detecting, like facial expressions or mouthpiece or any other part of the face. So the goal of the connectomics is actually bridge traditional neuroscience that has been focused on understanding how a single cell works with the psychology part, where how you make the decisions. Mm-hmm. And there's this big gap between going from single neuron to the 100 billion ones that you have inside your brain.
Traditionally in computer science, specifically in deep learning, there's been a lot of aspects of deep learning and AI in general that have been inspired by other disciplines. Neuroscience is one of them. The deep learning, which is based on neural networks, is loosely based on how human neurons work. And linguistics has played a large role in NLP research, for instance. Moving forward, we're seeing these massive models, things like GPT and other language models, that are more and more utilizing just data and compute and scale. How much of a role do you see these other disciplines, such as neuroscience and linguistics, continuing to influence deep learning? Or do you think that ship has sailed?
So what happened is that about 50 years ago in 1970s, you got this model of a neuron, which is very simplistic now. It's the base or the core of all the neural networks, artificial neural networks that exist today. And what happened since then is that we start developing an understanding how the brain works. Still, we don't have an understanding how the learning is happening inside the brain or how the memories are represented there. But we definitely know, like there's an algorithm called backpropagation that is used for training all these large language models. It actually doesn't exist inside the brain. And you can use connectomics to prove that out, that the way the neurons are connected to each other, there's no way formally that backpropagation can exist inside the brain. There are some variants or there are some other learning rules that are more biologically plausible. And the goal for this research was actually to use artificial neural networks to reconstruct the real neural networks to get a better sense of how this biological learning is happening inside the brain.
One analogy that's often made is like when they were initially building planes, birds and other animals that fly were an inspiration, but eventually those limitations were no longer necessary because they weren't necessarily just trying to replicate the way a bird flies, but just the flight itself. Do you still keep up with neuroscience research in those aspects?
That's exactly the case where you have the inspiration coming from, but then you end up with more optimized or maybe optimal solution that can, like in this case, try to solve general intelligence problem.
Because it doesn't have those constraints.
So after the 2 years, actually, I'm very loosely coupled with neuroscience. I took a course there in neuroscience, and also I think I was doing mostly computer science that was applied in neuroscience domain. But currently, while focusing on a company, we work not only in like biomedical image applications, which we do have a few customers on, but also like in self-driving cars with agricultural tech, entertainment, and etc. So unfortunately, I think even though that was a super exciting research part of my life, I'm like more delved into data infrastructure.
The data infrastructure side, yeah. We'll get to that in a minute. How many years did you spend at Princeton?
Overall, it was 2 years officially being full-time there.
Yeah.
And then I took the leave of absence, which took another 3 years as well.
Initially, when you were applying to Princeton, was it your intention to become an academic, to become a researcher? Or
yeah, that
did you always want to build a
took
company?
swings. So initially when I applied, I wanted to do startups.
Okay.
And I was very super straightforward with my advisor doing that. But then during that process, when I got into Princeton, got into the research and all the awesome parts of the science, I actually make a decision I want to be a professor. But eventually, for some set of events, I ended up back to startups. Yeah.
And what was it that inspired you to go back to startups?
I think the opportunity when we got into Y Combinator, we thought, great, this is like a 3-month internship. We'll do it and then come back.
Right.
But then it changed all the the spectrum, what happened afterwards.
So even while you were at Princeton, you were building what became Activeloop.
Yeah.
Okay. Tell us that story. When did you get started building Activeloop?
So the problem, initially it was called Snark AI, and we were doing slightly different things. So the problem that we had in the lab is that processing a petabyte scale datasets on the cloud was costing us a lot of money. And our goal was to reduce the cost from going from millions of dollars to 200 or 300,000 by rethinking how the data should be stored, how it should be streamed from the storage to the computing machines, should we use CPUs, GPUs, and what kind of models to use. And those inspired us to start, at that time called Snark AI, with fellow PhD students, where we started building prototypes, how we can make this computation much, much more efficient. And one of the ideas actually initially was to, how this crypto mining and crypto computations are happening, they're kind of a wasteful computation. We thought we can replace this with useful computation, in this case, reconstructing the graph of the neurons inside the brain, and then also like make the cost for this computation like 5 to 10 times cheaper. And that was the initial idea too.
What did that solution look like? Was it sort of like parallelizing the compute across people all over the country or the world?
Yeah, the parallelization was one part, and the second part was verification. So to make sure that there's no any adversarial like parties in the nodes that can try to fake the computation while earning money. And that's how the name came from Snark AI, which is based on ZK snarks, these zero knowledge proofs that prove the computation. But what we found out later is that the computation is very, very slow. So it's much actually more efficient to run this on the cloud versus get all this heavy lifting done while you don't get the computational benefits of running distributed manner.
Were you incentivizing users to like a token or something? Or?
The token was actually exchange of the computation fee that the
Got it.
person was doing.
Very cool.
We did a bunch of boosts, bunch of optimizations, but that ended up not a good idea. But that project itself helped us to get into Y Combinator.
You got into YC with that project?
Exactly.
What year was this?
It was 2018.
Okay. So there's a lot of excitement about sort of what we now call Web3 and
But at that time,
stuff.
we got in, and then there's like last few ICOs
right.
like large down, and then it's died out.
Right.
But when we found ourselves as between AI and Web3,
right.
and it's like between two hypes. And we didn't feel too much comfortable. I think being like having the math background and all the computational background, like try to, go along with the arbitrage and try to, do an ICO, will raise a lot of money. That doesn't really make sense. So we made a decision later that we want to focus on, especially on AI. That's our superpowers. And more specifically in AI is the data infrastructure piece, which is the most boring aspect of what's happening now.
Right. Tell us about your time at YC.
Yeah. So I think there's a funny story how we got into YC. is that we, with my fellow PhD students, we were like interviewing. They usually get just one interview and then you are in. They did a press screening for us. They did 3 interviews during that day. They had our competitors there as well, and they were back and forth. And then there's one question they asked us, which put us into a like kind of a weird situation. They asked like, what did you guys figure out that nobody else figured out? And me and my fellow PhD like colleague is like, we got surprised. Like we didn't know what to answer there.
Right.
And our third person, Jason, he's like, hey, we figured out how to run crypto mining and neural network inference at the same time on the GPU is much faster that you can do it separately. And then we got surprised, like, did we figure this out? They got, and then to our surprise, they also got surprised. Right. It's like, hey, that sounds awesome.
Right.
And send us the benchmarks.
Right.
And it was like, yeah, the computer is at home. We should run out and bring back.
Right.
Like, it's all the typical excuses you do at high school.
Was it accurate?
So
the statement?
We took an Uber, pretty quickly went back to our Airbnb, started hiking around, like actually showing and building these benchmarks. And we were like, Jason's like, guys, don't worry. We'll see how it goes. So usually in YC, they tell you the answer on the same day. They send you an email if it's a rejection. They call you if it's acceptance. Mm-hmm. So apparently we got the benchmarks and they were correct. So what happened is that Jason had used his subconsciousness to answer this problem solve based on the past history of like month of his reading and research time, but he didn't have the answer way before the interview. So that question itself sparked the solution that was likely correct. Wow. So we got the benchmarks, but at the same time we got an email. And it's like, guys, looks like we got an email. It's the rejection, so we didn't get in. And I opened the email. It says like, we can't reach you out. Just call us back. Okay. So apparently there was no any cellular connection there. So we called them back and said, hey, like they're like, we are in. Yeah. It's like, what about, we got the benchmarks. Like nobody cares about the benchmarks. We just wanted to see how you guys do.
It's like out of a movie.
Yeah. I think the point was that they less care about like, I don't know, the labels that you have or the like what you did achieve so far, because they know that you're going to be flexible and run a bunch of experiments. They want to see if you can figure out something that's like hasn't been figured out before, and that was their bet to accept us. And the other team, they didn't accept at that time, but they accepted on the next phase. So that's the overall YC decision. So during the YC was pretty actually useful and exciting. We were like PhD students from university, and like if you just to give you an expectation, you have Stanford, which is also like top computer science school in US, but everyone is there very entrepreneurial. Mm-hmm. And Princeton is like the inverse. Everyone's very theoretical, no business background, no like entrepreneurship mindset. People like likely go to a hedge fund and start doing trading afterwards or become a professor in theoretical machine learning. Yeah. So for us, it was like very, very opening to get into Silicon Valley and get connections and build from scratch there.
Right. You're from the whole other coast and very far from all of that. You mentioned something really interesting. You said they want to see some capability of being able to solve something that hasn't been solved before. If they recognize that, then they can take whatever idea you're working with and maybe help you mold it into something that can go to market and be successful. Do they actively work on doing that during YC? Like while you're incubated there?
Yeah, I mean, there are a bunch of companies in YC that the YC is usually 3 months project. And then at the end of 3 months, you do a demo day, which is their like place where you pitch your idea and then raise an investment. And there are so many companies, you will be surprised that they changed their idea on the last week, got a funding, and now like unicorn or billion-dollar worth companies. But that's happening in the last minute of your pressure. Maybe again, your subconscious is trying to figure out this problem, and you end up doing that.
Did Snark AI evolve into what became Activeloop during the YC process, or was it afterwards?
I think it was afterwards. I think one of us left back to continue doing his PhD, and then we started working with various projects to take on. The first project we worked with that had 80 million text documents. The problem was to build actually today it's a large language model. It was 4 years ago before GPT. I think the BERT, there's another language model that just got out. So we helped this company to train a model from scratch on 80 million text documents to build a patent search engine. And we also worked with another company, Intellinair, where they have airplanes flying over the fields, collecting a lot of aerial images and building insights for farmers. And we helped them to build the data pipelines early days. And what we found out is that you have all these awesome databases, data warehouses, data lakes, now so-called lake houses, specialized for analytical workloads. And for the context, analytical workload is like, hey, give me past 3 months of sales activity, or can you predict what will happen to my inventory next 3 months? But when you deal with unstructured data like images, video, audio, text, you don't have actually storage. So data scientists or machine learning engineers, the way they work with the data today is the same as developers used to work without databases. So we thought, why don't we actually go and build database for AI? More specifically, it ended up with being a data lake for deep learning applications, which we call Deep Lake today.
Right. Before you did that, you had to formally drop out of Princeton.
The dropping out of Princeton was pretty interesting.
I want to hear that story because, I mean, it's something that so many people really just aspire to. I mean, getting into Princeton is the highlight of some people's career. How do you make the decision to leave it?
Yeah, I'll never expect I myself will find myself at Princeton. So actually, initially, I wanted to become an animator, going to Pixar in animations and etc. So my dream school was not UCL, but UCLA in their animation department.
Oh, wow.
But given restrictions on computer science,
right,
I got into a computer science degree, so which I don't regret. So it's pretty exciting. I think the decision came. So what happened later after we started building, initially the name was Hub, Deep Lake today. We put it open source. It started building out. We got a lot of adoption. We'll deep dive on how we did that. And then at some point, I realized that I can have more impact while doing this on computer science itself, while compared to going back to continuing my PhD. So I remember very explicitly in I think June 2021, I got an email from my advisor. That email has two words: any decision ? We haven't talked to, I think, for a year or 6 months.
Right.
And then I looked into the forwarded email. So I see the graduate school pinging our computer science department, like, is Davit coming or not? And then there's another email going back. It's like, to the graduate school, we don't know. Like, do you have any information? There's like ping pong playing around. And then one of them saying, oh, wait a second, let us ask his advisor. And his advisor, I mean, my advisor as well, he was like at sabbatical. So he was being a president of Samsung AI. So he was in Korea and not fully in context of what's happening. And that was like during COVID times as well. And like, just finally make a decision, are you coming back or not? So unfortunately, I had to make this one of the decisions that either way you're going to regret, and said, it looks like I can have more impact on computer science itself here versus I go back and do my PhD. And that was the justification why I chose to continue working on the company.
It's interesting that you say there could be equal regret, right? If you look back and if you never started Activeloop.
I think one of the key things when we got after YC, I flew back to Princeton. I met my advisor. He's one of the best people, like the smartest folks that I've ever met. And he's like, ask, what do you think? What should I do? And he's like, look, like, you can come back now and continue your PhD, but you're going to always think, what if you did the company? So go and try out. It doesn't work out. You can always come back and continue your PhD. So I think that was one piece of advice that really liked. And then there was another professor, he was head of department. He also running a company, another in databases, as well as like, look, like, you can do both the PhD and the startup as well, but you're not going to succeed in any of them. So just pick one, focus, and make that successful. If it doesn't work, just switch back to the other one. But be focused on one at a time. Yeah,
having that focus is super important.
Yep.
Okay, so let's get to the product. You said it was initially called Hub. Take us through the evolution.
Yeah, so what happened is that in our lab at Princeton, we had this project called Cloud Volume, which was helping us to maintain these really large volumetric images of like a very small, tiny piece of mouse brain. So think of it as you can store 100,000 by 100,000 by 20,000 pixels, which is a petabyte, and petabyte is 1,000 times of terabytes, what your laptop can contain, so thousands of laptops. And we had this very thin layer that could actually access any part of this data. You don't need to store the whole data set in your local memory. You can store that on the cloud, but it feels like everything is on the local machine. So we took that concept and then said, okay, why don't not only store like 3-dimensional or 4-dimensional data, you can store also 2-dimensional data like images, videos, or labels of the annotations of the data itself. And then one trick that we figured out that nobody has ever done that before is that we can very efficiently figure out how to stream the data from storage remotely over the network to the GPU as if the data was local to the machine. So what this allows you to have is, now you think of it as like Netflix for data sets. You can stream the data without waiting until the data set will be copied to the machine, but also you bypass the limitations of a local machine. If your local machine has only terabyte storage, you can actually have now 10 terabytes of data that's constantly being streamed to your GPU while you're training those models. And as models grow, as data sets grow, this becomes more important.
And the focus initially was on just computer vision on image data?
Yeah, so we made a choice where to focus on, and fortunately or unfortunately, I don't know yet, we focused on computer vision. So that's where our initial user base got in. We started running webinars. We started running a bunch of podcasts as well, like on getting into different various developer meetups, and then explaining what Hub at the time Deep Lake is today. And we found ourselves like during the COVID time, so everything is remote and trying to get adoption. And we saw that like our GitHub started to grow on every meetup we do, and eventually took off and became the second trending across all GitHub repositories in GitHub, and then first one in Python language. And surprisingly, what was the first one at that time during GitHub? It was a crypto trading bot. Okay. We couldn't just beat that crypto trading bot because people prefer to get easy money versus
for sure
data infrastructure.
So all of this happened in the last 2.5 years, basically. Okay.
And then we started building a community as well. Currently, we have about 1,100 data scientists and data engineers in Slack, focus on Deep Lake exactly. And we raised additional funding as well about 2 years ago.
So Deep Lake is the name of your product. It's a data lake that's optimized for deep learning. Speak a little bit about what data lakes are and why they're important to the entire machine learning ecosystem.
If you look into the history as well, what happened is that a lot of companies about, I think, 10 to 15 years ago, when their data grew a lot, they need some location to be able to store the data. So what happened is that you had a lot of data silos, a lot of different locations. Let's say you have 2 databases services running here, you have another file system located on these machines, and then you have this disparate data where your organization is suffering because not everyone has access to all the data sets itself. So that was a kind of a decision, which later people regretted, but in the beginning was this idea of data lake where we can take all the data and store that together. So that's how the data got organized. And then through the cloud enablement, I think there was like this object storages where they became like very native data lakes. But before that, it was Hadoop and HDFS, where you could store all the data there. So, however, what happened later, this is the first generation of data lakes. These data lakes became data swamps because like everyone just started dumping all the data the way they think the data should be stored on these data lakes. And it became very, very difficult to parse and go through this data. And these data sets both include structured tables, like, I don't know, Excel data, the way you interact with, or like a bunch of images, videos, etc. And what happened afterwards, there was the second generation of data lakes, which today is like they're called Delta. Like one of them is Delta, the other one is Hoodie, Iceberg. What they focus on is like, okay, can we take these structured data sets and better formalize them on data lakes? So can we make it like such that it's very, like there's a schema, there are query engines that can directly access the data without any complications. And then there's also version control on top. So you can track how the history of the data set has been changed on. And that's how the second generation of data lakes come into the place. And what Deep Lake is you can think of it as an extension of second generation of data lakes that now also store images, video, audio, along with the structured tables as well. One of the key innovations was that we not only treat single columns as like one-dimensional data, but now we can have this n-dimensional data. If you take a step back, so what the inspiration was from is from deep learning computation, where today neural networks, they are built on this tensor frameworks like PyTorch or TensorFlow, and they take in a tensor, and tensor is just an n-dimensional array, and they take an output as a tensor out. They don't care it's a video, audio, or it's a one-dimensional data, as long as it's in tensor representation. So what we looked into deep learning computation and said, hey, what if we take this and then look, what is the best way to store this data? And that's how our tensor storage format come into the place. And now getting back is like, it's an extension of data lakes 2.0 to be able to also store the rest of the unstructured data, but now structured such that it can be efficiently consumed by AI models.
And so nowadays, you guys are not solely focused on computer vision. You support all types of data formats within your Deep Lake.
Yeah. So we extended to point cloud data, to biomedical images like DICOM or Nifty files like CT scans or fMRI. We support textual data as well. The one-dimensional data is like just a natural extension. Like if you come and say, hey, I have like a big like billion row table, we'll like there are better tools like, I don't know, any of the data lakes that you like formats that you take. But if you say, hey, we have also unstructured data and we want to do deep learning, that's all the benefits come from doing the Deep Lake. And what we further extended is that we took not only just the storage, we built a query engine on top, which we call Tensor Query Language. It is an extension to SQL, but now it can actually not only just filter the data, let's say give me all the images that contain a bicycle during the raining day, but also you can say, hey, crop my images, go and order by area of intersection between my predictions and the bounding boxes that exist inside the ground truth. So you can have more flexibility on slicing and dicing the data sets, because SQL originally has been focused on more analytical workloads, and TQL is more focused on building data sets to train the models or fine-tune the models on top.
Right. Let's talk a little bit about growing your user base over the last few years. Has being an open source project helped you get your initial users?
Yeah, for initial users, open source is great. You get this first feedback coming into, and like, I don't know if you know, about building a database takes 10 years. And you really need this first feedback coming to your product so that you know the direction that you're heading to. And in that regard, open source has been like super, super important for us to shape the product, to get understanding what are the pain points, to get initial customers and their traction as well. So that's great. But then also it's a double-edged sword. Then it makes it very difficult to go and sell the product, because when we go and sell this product, they say, okay, why should I pay you? It's like, it's free. But like, we spent all like last 3 years building this, and like, it's kind of both like great, you get the option, bad is like, you have to figure out the business on top.
Recently we had Georg Solomonian on the show from AimHub, and he made this great point where he said you have to almost find a way to keep a certain set of features not in open source. But the challenges that he described was then your open source community is so used to getting these things for free. I hope I'm not misrepresenting what he said. They're so used to getting it for free that you sort of risk pissing off a certain portion of your user base. How do you think about what features that are in the pipeline to include in the open source version versus commoditizing it?
Yeah, Georg is awesome. We think a lot on our insights about the open source overall. Also, we did kind of interviews or / like talk to a bunch of like open source leaders for example, like who build Spark, who build let's say Nginx, and other very, very famous, or like Docker, etc. So all the open source tools. And there are a lot of philosophies how you can tackle this. There are a lot of like problems that people figured out, and it's like very custom to each use case that you are building up. The one that I think that, to answer your question in short, I think the advice that we received is that just open source what the thing that gets the most commodity to be on the edge, and then the rest that's like the later towards not commodity that you can keep still private source. And currently what we have is that we have the deep lake, which is the format, the version control that is open source, but we also have the TQL, which is the tensor query language, the visualization engine, and also the streaming engine, the much faster one than compared to the open source. That's private source, and they're implementing different languages, and there's a lot of like performance versus enterprise support compared to open source and availability.
Getting back to the product and just sort of the general AI landscape today, the biggest thing over the last year has been sort of this advent of these foundational models, which are these massive models that can, at this point, do a variety of things. This week we saw GPT-4, which is multimodal now. I want to talk to you about that in a bit. How does that impact people like you who are building at the infrastructure level, at the MLOps level? How does your product need to adapt to fit these kinds of models?
If you build this like kind of a pyramid of what from the consumer of the user, let's say of ChatGPT, till it gets into the infrastructure, you can have these different layers. And then on the bottom, you have the GPUs, which everything, currently the biggest beneficiary of this whole ecosystem is NVIDIA, which is selling these GPUs that all these foundational models are trained and deployed on. Then you have this MLOps stack, which is annotation tools, which is the data infrastructure tools, like training tools, evaluation tools, etc. Then you have these foundational model companies like OpenAI, Cohere, Stability, etc. And then now the new layer is being like kind of built up, which people call it LLM ops or FM ops, whatever, which is focused on how to bridge the API to actually a consumer application. And there are tools like Longchain, Llama Index, and others as well there. And it's like a fast-growing field. And then at the end, you have these vertical applications that's like looks like ChatGPT. You have this Jasper AI, Copy AI, and all the other like gazillion now startups that are booming every day in Silicon Valley. But like one thing that's pretty apparent is that currently Silicon Valley is like drinking this hype of generative AI, and also it's like it's not a fake thing. It's not at least people say it's not like Web3, where you have this highest expectations, you have this pyramid of schemes that you can make a lot of money.
There's actual value in being created.
Yeah, definitely GPT 3.5 or 4 like supersede the expectations that people had while interacting with conversational AI in this case, or its ability with stable diffusion. You can now generate for photorealistic images that hasn't been possible before. So those are definitely remarkable technologies, and they are shaping and shaking the whole not only technology industry. Like it's very funny. I was in Digitech about a week ago, and I took Gigi driving back to our office, and on the way he was hearing my conversation, and then at the end, once I'm done, it's like, hey, like, do you know that I was doing Python development from 90s?
The driver?
Yes, the driver. was like, oh, awesome, that's pretty cool. And at that time, nobody was
doing Python.
doing Python, and it was like a scripting language.
Right.
It's like, oh, that's unfortunate because currently Python runs everything.
Yeah.
and he's like, I'm actually now building a ChatGPT application on top. And it's like, wow, that's like pretty impressive. He's not talking about his businesses that likely was running somewhere abroad. He's talking about building an application using ChatGPT.
Yeah.
He's like, dude, you should, yes, that's everyone is doing now in Silicon
The
Valley.
traditional story
Exactly.
was like a Moscow business or something.
I'm waiting for his startup. Like, I'm introduced to a bunch of investors.
Right.
So,
That's fascinating.
yeah, and that's pretty great. I got pretty
Yeah.
much inspired from
Yeah.
that conversation itself.
Right. One analogy that I thought was really interesting that was made recently by a prominent Silicon Valley investor was that during sort of the gold rush, the companies that made the most amount of money were the people building supplies for getting gold. So like the pick companies and the shovel companies and things of that nature, because extracting the gold and all that was extremely expensive. So the margins were thin. And the people who were just making stuff with the gold to sell it also had low margins and high cost to produce the goods and stuff. So the NVIDIAs of the world are kind of the pick companies and the shovel companies. But the MLOps companies also sit in that space, I think, because anybody that does machine learning at production level needs to use MLOps to bring that stuff to production. One of the things that's really exciting is that in Armenia, we actually have like a number of, including Activeloop, a number of really exciting MLOps tooling companies. Suprantate is one. You guys, AIM is a big open source project. Monot is there now. Recently, you guys announced a partnership with Monot. Can you tell us a little bit about how the two of you help fill in that MLOps?
Yeah,
pipeline?
let me do I have a couple thoughts
Sure.
about the gold rush.
Go for
before
it,
we get into there. So I think there are very, very nice parallels of what happened, I don't know, 150 years ago in Silicon Valley. There was not called Silicon Valley like at the time.
Gold Valley.
Yeah.
I'm kidding.
So the thing is that, first of all, what's happening today is great, is because the cards are being reshuffled. And then all these big incumbents and also like small startups, they have the same initial start time,
Right.
which is a great opportunity for those people who are just starting out. Second, when there's a gold rush, you don't get confused. You take the shovel and start digging. So that's the second kind of advice I have for,
Right.
I don't know, starting from drivers to
Right.
the startups here.
Right.
Third, which I think you mentioned it very well, is like when there's this arm race and there's also the development of many foundational models or fine-tuning of those. What we can be the best at is actually be an arm dealer where we sell tools to those people to be more efficient, to build their unique differentiation. It's us, it's Suprantate, it's, I don't know, Monot, or it's AimHub. Doesn't really matter as long as we are into the game and we can show the benefits to those companies. So luckily for us, our technology itself has been focused on building the storage layer, which is kind of a de-risk from either you do supervised or unsupervised type of learning, and this foundational model training are mostly on unsupervised learning, and there's the last piece of fine-tuning, but there's a very small amount of data that you need. So actually, a lot of people were being confused before this generative AI trend or hype, saying what Activeloop is doing here. So like, why do I need to use Deep Lake? My current storage is good enough, and etc. But what we've seen, the same people who were like arguing back, why do I need this? They messaged me like saying, hey, like now it makes sense.
Right.
Now it like totally makes sense what
Right.
you guys do. And then we had even this scenario where guys at Waymo, they're building their self-driving car technology and the data infrastructure there as well, now started referring their internal tooling like Deep Lake, which is like a great, now we're getting a mind share as well. So that's the positive side of things. Now looking back, is not just one tool can win here. I think in the like gold rush, you could sell shawls, you could sell, like, I know people who build a lot of hotels and they rent it out, right? But they sold the hotels to some other people who banked the money. So that the building the hotels was the big business at that time as well. So like still like everything is unclear and there's a lot of uncertainty, but it's a great time to figure this out. Plus you have this recession. I think what happened last weekend is like also pretty remarkable. Like after the biggest bank after Lehman Brothers got collapsed, Silicon Valley Bank, and for a very, very unclear reason why, aside from just panic, removing the money, I think about $42 billion in 48 hours. So this is like essentially is like Wild West times in Silicon Valley, which is great, like once a generation time to be there. Now, getting back, I think what we can do together with the, especially in companies here, startups in Armenia, is they actually get together and build more like full package solutions that can actually benefit the value to the customers. And that's one thing that we did with Monot is that, hey, to build your data flywheel, you not only need the storage, but you also need the sampling and sampling of the data that has the highest impact on the training process. And that's where Monot integration makes a lot of sense. We also did collaborate with AWS. We did collaboration with Intel as well on partnership side. So I think what we are seeing today is that you had so many MLOps companies, like even so many that they're just conflict with each other in the market, not only in Armenia, but also in US as well. And since the funding is drying down, a lot of these companies need to find a lot of customers to become profitable. There will be a lot of consolidation. And during this consolidation, there will be also a bunch of integrations between these companies to make sure that the end consumer workflow is very well supported. So,
do you think the consolidation will happen between MLOps companies, or will the sort of the cloud computing providers sort of gobble up some of these companies and just provide them at the cloud level? Because a lot of that compute and a lot of that training still happens in cloud infrastructure.
Yeah, to our surprise, for now, at cloud computing and others, 3 different players here. First one is like consulting companies. I think consulting companies were the first to buy these MLOps companies. So the HP bought 2 companies, I think Pachyderm and Determined, a year ago before as well, to build up their tooling for selling to this, like not HP, but HPE, which is their enterprise arm for doing consulting. I think there was another interesting acquisition as well by McKinsey buying Iguazio. So that's another MLOps company based from Israel. And the consulting companies were the first to do this. So which means that they see the value, they see the initial value to their customers. I think as you said, there are cloud companies like AWS, Google Cloud, Azure, and what they're optimizing for is bringing in this foundational model training into their platform. I think Azure and Microsoft did an amazing strategical decisions to invest into OpenAI to have all these funds. Google has TPUs, and they also funded recently Anthropic to also like move their computation there. I think Midjourney is also doing the training there as well. So then AWS is now like doing a collaboration with Hugging Face to get the training there. So there's like clouds are now trying to optimize to train and deploy these foundational models on the cloud. And that's where our partnership with AWS also makes a lot of sense. Then you also have now much larger, bigger data infrastructure companies called Databricks or Snowflake. They're also like trying to see how they can fit into this whole space. So if you ask me what is the likelihood of and Databricks did a bunch of investments in MLOps field, including companies like Tecton, Labelbox, etc. So I think Databricks will end up with buying a lot of those MLOps tools, or otherwise building that internally and offering these customers, because they have the biggest revenue in this kind of MLOps. And they're less MLOps, they're like more modern data stack type of a company, but they will like formalize all this infrastructure platform.
I never thought about consulting companies as a natural buyer, but it makes a lot of sense because more and more businesses are trying to integrate machine learning into their core businesses. An MLOps expertise within the consulting companies is a really natural fit.
The theory I have is that because there's so with AI, you have so many different use cases. It becomes very, very tough, and we have seen ourselves as building a product that's scalable across different customers. And then if you have few customers per each vertical, then what you end up building is like very customized solution for each of those customers. And then you don't end up with a product, you end up with a consulting service, like a company, like public company. The biggest one is like C3 AI. They're like a pure consulting company in a package of a product company. And even, or like, I don't know, Palantir as well. There's like, if you can make a business, that's great. It doesn't matter you're a consulting company or a product company, right. But that becomes a natural extension that the consulting companies find the most like much between what you are doing and what they are doing,
right.
And then they can help you to scale across their organization. So that means that we will still see down the road a product company, which we haven't seen yet, that will be an AI company. I think OpenAI is the most nearest one with their just an API interface. Like even like one of the biggest annotation companies, Scale, which is I think around 10 billion valuation. They are essentially the core of the business is doing annotation service, which is a consulting. Even though they hide it behind the API, the data is still sent to someone in Philippines. They do the annotations and back and do that. So we'll need to see a product company in AI. And this is a great opportunity for product people as well, because now the product is being reshaped from scratch as well. I think Microsoft did the announcement of their Microsoft 365 Copilot, right, which gets into Word, Excel, and everywhere to help or enable or reshape the way those products are working.
When you say we will still need to see a product company in AI, do you mean product companies that utilize AI or something new like OpenAI that we hadn't seen before?
I believe my bet is something new that we haven't seen before. rather than what OpenAI is doing. I think maybe built on top of OpenAI API, maybe another foundational model that doesn't really matter. I think Jeff Bezos has this famous internet schmeternet, doesn't matter,
right.
as long as you solve customer problem.
Right.
So I think that what we'll see aftermath of both the financial situation across the world and also the hype, and then it's a lot of people compare 2008 with mobile and the financial crisis. So it's a pretty exciting times. Again, the cards are reshuffled. Everyone has an opportunity from anywhere. So I think just getting in and trying to build stuff that's useful for the customers.
It's interesting to hear you describe all that as an opportunity, because a lot of people I think are describing it as more like panic.
But that's when there's a panic.
That's when there's opportunity.
Yeah, you don't get panicked. You take the shovel and start digging.
Exactly. That's a great way to put it. Let's get back to foundational models for a second. So we're recording this in mid-March, and this week we saw GPT-4, which is a multimodal model. It's not the first multimodal model to ever be built, but it's probably the first one that popularized sort of it in the public. And all multimodal means is that traditionally machine learning applications have been specific to some modality like vision or language or audio maybe. GPT-4 is able to handle multiple modals, text, images, I think audio as well. How does your Deep Lake product fit into this? Because you guys handle these different types of data formats, right?
Yeah, so our initial bet was things going to be multimodal. So I think we were slightly ahead of trend, and I'm not sure if it's good or bad, because if we focus on, let's say, on textual data or tabular data, maybe we'll get much more adoption today, and then we'll have the flexibility to switch to multimodal.
Right.
But then we started from the other end.
Right.
It's like, hey, let's build a multimodal, which is this is long tail of problems that are very hard, challenging, and is still a challenge for us to make sure that all these use cases are perfectly working. And we see even same customer, same different teams in the same customer set, they use the same tool with different use cases and they break things. And it's technologically very, very difficult for a small team of a startup to be able to contain and sustain all the possible use cases that a tool can be used, especially it's a generic data infrastructure product. So having said that, going multimodal is our motto. Is we're super excited, because what will happen, what we will see is that all these databases that currently are used, all these embedding vectors, search stores, whatever they have, they're going to fail. They're not going to work with storing images. And that's where hey, now it's a natural extension for you by default look into Deep Lake, where you not only can store your textual data, analytical data, and also this vector data, but also images, video, audio. And that GPT-4 out, there's still the image section is not yet fully supported. I think soon will get supported. And then you will see all these tools, they will start multimodality inside. And then that's where hopefully Deep Lake will get into much more traction. I think our number of downloads multiplied by 10x by this GPT-3, GPT-4
craze.
Hype. Yeah.
One thing I think we don't see yet, but we'll start seeing soon, is multimodal in production. I think that's fair to say. Most applications of AI are still unimodal. Do you think it'll take a long time for multimodal applications to be realized in production, or do you think the use cases are there today? Because oftentimes some of these exciting technologies will be built and shown, but it takes a while for it to actually come to market.
You will see the same thing. Maybe after 4 or 6 months, this generative AI hype will go down, and they're like, oh, why did we need all this cool technology where we can't find a business use case here? And then it will plateau, and then this hype cycle go back, and then the meaningful applications will be found.
It's a multi-year thing, you think?
Right. There are certain use cases where multimodality really helps. It could be in pharma, like in drug discovery, where you have product instructions and a bunch of textual information to parse through. It could be in healthcare, well, you need to look into the CT scan, you look into the patient diagnostics that has been doing before, and then make some conclusions. A fun fact, what happened recently as well, these large language models passed the so-called test called UCMLE. So if you're a student, want to go into US and become a resident there, medical student, and you have to pass this UCMLE, a lot of people fail, and now these models can actually pass the grade to become a resident in US, which is a pretty interesting. Yeah. I think GPT-4 also published their benchmarks across all different bar exams.
The bar exam, LSAT, SAT, everything, yeah.
And it's funny because I was very bad at giving this SAT exams. I was very bad at doing the GRE. So I'm great. This doesn't really mean anything. It doesn't help much. Now I just passed this. Great. And we see a lot of universities are shutting down all these requirements, which is good. Coming back to what multimodality actually enables, there's also a lot of hype. With generating these images, great. You have this creativity, you have this entertainment. You can actually decrease the cost for creating a high quality content. So my dreams making Pixar animation, the reason I didn't finish that path is because you need people of at least 200 people to build like a full-blown animation score. And now if you can do it with few people, awesome, that's right. Anyone can be a creator. So we are afraid that this will replace artists, but it actually enables more people to become artists. And not only in like image space, but also in coding space. Now, like essentially the first thing that AI solved is the hardest thing that we thought initially that we'll never solve, which is the creativity aspect. And now we have the coding as well. Great. Like I don't want to do coding. Like I'm a developer myself. We have a bunch of developers in the team. And eventually if I can translate my thoughts into programs or applications or products much faster, it's awesome. Like that's like, I think everyone should be inspired and better like focus on that. So I think that multimodality was going to help, but it might not be the multimodal that you expect things will turn over.
What do you mean by that?
I don't know. You expect like image plus text will be the use case, but actually image plus code.
Right.
And the code is different modality in this perspective.
Right. Your company is headquartered in Mountain View. You have a large team here in Armenia. What's that split roughly? Can you tell us?
Overall, we are 15 people. We have 7 people here in Armenia. We have also 3 engineers in India and 1 engineer in Kazakhstan as well. We have also 4 or 5 of us are in US, in Mountain View, in Boston, New York, and also a few folks from Miami as well. So one thing that I think I mentioned at Digitech as well is that we are building a very complicated product. And it's like, you might think it's great. We are great, very intelligent people, but actually it's like super hard, super painful. And if you wanted to make money, there's like much easier ways to make money. Right. So don't do this. Like, yes, I've seen a bunch of people, and unfortunately, the space we are at, typically people are slightly crazy, which is great and bad at the same time. So then what we achieve is that we managed to build Deep Lake and publish a paper at one of the top database conferences where like top researchers from Berkeley, and then Berkeley, just for context, they spin out all the major infrastructure startups that you have seen last 20 or 30 years or even more. They came up with a database and table schema, etc. So they are the fathers of everything. They also came up with Spark and Databricks, like there's also Ray and other bunch of famous projects. And we could publish the paper in the same kind of area where they publish paper. And the interesting thing is that if you look into typical startups, what they do, they outsource their like non-core development to India or to Armenia or to other place. In this case, the core has been developed in Armenia.
Right. So
all this like technological innovation that we bet on has been developed here.
Your core engineering, everything is here.
Right. Correct. So I think that means that eventually you can take any aspect, you can even train a foundation model here as long as you have the resources and know how to do things. So as long as you can translate what's necessity in the market and bring that communication, which is an overhead, to here or to some other location, doesn't matter where, you could send to Africa or Europe or Asia as well, doesn't matter. And find the right people who can solve it, even though they might not have the best experience for solving this. But a lot of engineers from our team, they worked before at Synopsys, they worked at Xilinx. One of the engineers who is in Armenia now, but like temporarily visiting us, he's based in India. He has been number 2-3 contributor of Keras, which is a big TensorFlow-based deep learning framework. And he has been like all the time in India. So we have all these awesome people, and it's not just us. There's not an us thing to be proud of. It's like you can do that as well.
It's just the nature of the world now.
Right.
The world's a much smaller place.
And then you have all this talent that undiscovered that you can build really awesome technology products and compete against what's happening in Silicon Valley, while you still need to understand what's the trends that are moving there.
Right. And Davit, my last question. Where do you hope to see Activeloop in the next 5 years?
Well, so I think the number one goal we have is to standardize and deploy Deep Lake as the main format for storing machine learning storage data, and then enabling deep learning applications. And now within this context, as we see, like maybe a year ago, you're like, hey, why do we need deep learning in production? And now everyone is claiming they're an AI company. Everyone is using the OpenAIs or Coheres or this API. So that behind the scenes, they use deep learning models. So the goal for us is to enable them by having a very efficient storage. Because what we have seen is that it could be a mistake, it could be a right thing to do, depending on how long-term you're looking into, is that Deep Lake is a phase 4 operation, which means that you have to do phase 0, which is you're building your application. Phase 1, maybe start fine-tuning the model. And then phase 2, phase 3, phase 4, while you get understanding, now I need to optimize my whole data file with like much better technology tooling. So we'll see more companies getting into phase 4, and that's where deep learning will be most helpful. But at the same time, what we are doing, we are simplifying this to make it useful for phase 1 and phase 0 as well, so that the adoption can be increased as well.
Right. Yeah. No, that's really interesting. David, thank you so much for joining us today, and I wish you a lot of luck with that.
Likewise, Najat, great chatting. It's good conversation, and thanks
Yeah,
for having me here.
I
as
enjoyed
well.
it. Thank you so much.
Likewise. Thanks.